in direct messaging, if you provide me, so I'm going to write it here, provide me 2 days of the year in DM. We'll just, we'll abbreviate. We'll say DM because then it'll make me sound like I'm cool. And so what do I mean by that? I mean month, day. So give me the month, day, please. All right. And so I'm going to give a couple of values myself. Okay. So my values are going to be 1:15 and 9:29 and 5:22, 10:15. All right. So randomly here, I have 4 different month, day, days. Right. So this is Ben. I'm going to put Ben right here. So in our class, I asked you to provide me two values. And so with the birthday attack, just to remind you here, any hash is tested for vulnerabilities with the birthday attack. Okay. And so what does that mean? What the heck does that mean? That means that in what we call a finite key space, if I have let's say I have a wooden box. So in a finite key space, what we would do is, it's kind of like if you had a box or, a container of some kind, this finite key space. And in our particular key space, there is, for our particular purposes here, there is 365 possible values for us. So there's 365 possible keys in the month, date format. And so if a hashing algorithm has the confinements or the limits or the boundaries of a finite key space. So what that means is, if there is not what Buzz Lightyear says, to infinity and beyond, right? If there is a finite, in this particular case, 365 values, then we can predict with relative confidence that within 23 entries, we can force what's called a collision. So let me just copy and then put this on here so I can do 23 entries. We can force a collision in this particular example. So for our purposes here, I'm showing you how the birthday attack works. So if you create an algorithm and that algorithm has limited number of keys, what we can typically do is, within 23 entries, there's going to be a pretty good chance that we're going to, 2 of us in this room or in this class are going to put the same value. After we get to the 23rd round of entries here, we have basically a coin flip chance. So the over 50% chance that each subsequent entry, 24, 25, 26, 27, 28, so on, gives us a greater percentage as we move closer to the end of that finite key space. So once we hit 23, we have a 54 or 53% chance. Basically, we're flipping up the coin with each time that I enter something here. So check it out. I'm just going to go through here, and I have that is a month identifier, not a, oh, you sent that 6 minutes ago. Sorry, I was in the middle. So let's go through, and I'm gonna just go what I have on my screen here. I have, you provided 61601 and 1201. Okay, thank you. All right, you did 1-1 and 12, 12. Did 4, 13, and 7, 22. Thank you. 7, 23, and 6, 18. So far we don't have any collisions. And we've entered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 entries. We don't have any collisions, right? So we've not done it yet. 3, 27, and 1, 26, 8, 13, and 5, 24. July, and just reversed it, it looks like, 4, 7. So far we don't have collisions. We don't have any. Oh, and then there was. Thank you for playing my little reindeer game. So my wife's birthday is 9/29. What significance is that to you?
September 20, 2019, I got sober.
Oh, big day.
Yay.
Big day, right? That's big time, man. All right. So what we just did there is we just forced a collision. We proved the concept that I was just talking about with the birthday attack is after 1, 2, 3, 4. So what I'm going to do is I'll highlight it up here so you guys can see it. So after, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. On the 20th entry here, that's what this is, 20. We had a collision. I said 23 entries, we got a 50% chance. So we forced a collision. So that means that if you put in a key, so if you have a key value and it's a finite key space, in this particular case, 365, we can predict with relative confidence how quickly we're going to be able to hit that collision. And so here on the 20th round, and I put in the same value, and now we're on the 22nd round. So then next here, we're going to start seeing, even with basically almost every one of these from now on, it's a 50-50 chance on whether or not we're going to actually get a hit. So let's keep going. And again, I'm just doing these in the order that I received them. 9, 24, typing them in here. So now we got what, 20, this is the 24th, 619, oops, 619, and 1225. One of my favorite days of the year there.
Yeah, I actually had 2 collisions and has 1.
Oh, really? All right, who was I there?
Oh, I'm sorry, 1201.
Okay, 1201, and oh, there it is. Look at that, 1201. Boom! Look at that. Look at all these collisions that are popping up here. Boom! I mean, I was just saying 1, but shoot, we've had we've had 6 of them so far. But you know what? The party is not over. Let's keep doing this. Keep doing it. Because I don't want to leave anybody behind. So I'm sorry, 2-1 and 11-6. So 12, 25. Boom. We got another collision here. This one right here. And you guys are tied together there. All right. So here is the manifest of entries. So I think you get the gist of it, right? But then that would exponentially increase the key space if I asked for the year, right? Think about that. If it was a 2-digit year or a 4-digit year, the key space would go up through the roof for both of those. But since we can contain it and put it into that box of 365 values, we can predict with relative confidence that super quickly we can force that collision. And so hashes, passwords are usually stored in hashes. And so rainbow tables is a massive table of password hashes. And so if we can get the hash of a password, like let's say an NTLM password in Windows, then we can compare it to other known password hashes and get that collision, then we can crack that password. which is kind of cool if you take the applied science behind it and actually put it to life with that. So in our case right here, you know, the 50% or greater was right around here. And you can see here, here, and here, you know, we had the collisions. We had collisions. And that's what, 1, 2, 3, 4, 5, 6, 7, 8. That was 8 collisions out of 42. 8 collisions out of 42. And so as we would continue to collect data here and, you know, randomly put in things, since we have this many entries, it would be 50% or greater with each subsequent one. And it would move north of that, closer to 60, and then as you continue to collect 70 and 80 and so on and so forth. But this is just kind of cool. And so that is what we use for attacking hashing. And that's a vulnerability that's known for that.